Okay, so question 8 says two events A and B are such that the probability of A equals 3/5 and the probability of B equals 1/4. If A dash denotes the complement of A, calculate the probability of A dash intersecting B. Alright, so just to make that really clear, imagine we had, oops, what's happening with the colours? So we have the entire universal set here, and we've got A and we've got B. So everything that's not in A is all of this region here. So everything that's not in the red bit. Hopefully that makes sense. So the green dashes equals the complement of A. Alright, so it says calculate this guy when the probability of A union B equals 3/4. So A union B is the whole A and B put together, so including that middle bit. And the issue is that when we add the probabilities together, we count that chunk twice, if that makes sense. So we have the addition rule of probability that says the probability of A union B, so that yellow scribbled in bit, is equal to the probability of A plus the probability of B. And we've got to subtract away the intersection of PR of A intersecting B. Now the reason we have to do that is because this and this have both included that little bit in the middle, the blue bit. So we have to subtract away one set of it so that only one remains. So we have A union B equals 3/4. We have the probability of A is 3/5, and we have the probability of B as being 1/4. And now we should be able to find A intersecting B. So we've got, if we just quickly combine these two, we'd have, what's that, 12 on 20 plus 5 on 20 equals 17 on 20, hopefully. And this guy is going to be the same as 15 on 20. So doing some basic maths, we subtract 17 on 20 from both sides and we get minus 2 on 20 equals negative PR of A intersecting B. So let's just write that out a bit more nice. A intersecting B equals 1/10. So you might not quite see why we've done that yet, but what I'm going to do is construct a probability table now that's going to make use of the information I just found. So a probability table set up like this: A and A dash, B and B dash. And we know that the whole probability is 1. We know that the probability of A in the green up here is 3/5. We know the probability of B in the orange is 1/4. And we've just found in the blue that the intersection between these is 1/10. So might also be easier to see that as sort of 0.1. And that guy down here would be 0.6. The orange would be 0.25. So we want probability of A dash intersecting B. So we want to find the probability of A dash intersecting B. We want this column, well, this element right here. So we just need to find what adds to 0.1 to give 0.25, and that should be 0.15. And that's our answer. So just to make that really explicit down the bottom, the probability of A dashed intersecting B is given by 0.15 for this case. And that's this box right here. Alright, so the next question builds on this information we had previously. We're now asked to find that probability of A dash intersecting B when A and B are mutually exclusive. So mutually exclusive events have absolutely no intersection. If one occurs, the other one can't. So here you can see that PR of A intersecting B equals 0. So if A and B are mutually exclusive, we have, I don't know, let's have a crack. Probably set up the same probability of table. So A dashed, B dashed. So in the green we're going to get that 3/5. We're going to put that down here as 0.6, they're the same thing. And here we're going to take our quarter, put it here as 0.25. Now we know the intersection of A and B equals 0. That's this guy here that we just found. So when we add across this column here, this row, we should get this value is 0.25. Adding down this way, we should get that that's 0.6. That should be here, if we kept doing it, 0.4, 0.75. So that would be 0.15, and the whole lot adds to 1.0 if I wanted to complete the table. But the bit we're interested in, probability of A dashed intersecting B, is here. So just to make that really explicit, the probability of A dash, the complement of A intersecting B, is given by the red box, which is equal to 0.25, and that's our answer.